Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over question number 1 to 5 of our 2020 AP Calculus AB multiple choice practice problems. Don't forget there are 5 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of the examples that we're going to go over in this presentation. To gain access to the entire course list and other valuable learning resources, take a look at the link in the description below or just visit our website. And if you haven't already subscribed, go ahead and do that so you can get updates to all the math tutorials we upload to our YouTube page. All right, let's take a look at question number 1. Question number 1, we're being assessed on how to find the indefinite integral, okay? So question 1 reads, what is the indefinite integral of x to the 5th over 2 dx? Before we get started, let's take a look at the formula that's going to guide our problem solving process. So how do you find the indefinite integral of a constant multiplied by a power? Well, one thing you can always do, you should always do when you're integrating is if you have a constant multiple, you always want to factor it out of the integrand, okay? But never factor out variables from your integrand. Variables you're integrating with respect to. So we're integrating with respect to x, so we never want to factor out any x from the integrand or else our result will be incorrect. Okay, so notice I factored out the constant multiple. Now I'm going to apply the power rule here, and this is going to be k times x to the n plus 1 over n plus 1. And don't forget, whenever you're finding the indefinite integral, basically if you have a and b, that's definite, okay, because you have an upper and lower limit, so it's defined where you're starting and stopping. But if you don't have any numbers there, that's indefinite. So do not forget, anytime you're finding an indefinite integral, you always want to add your c plus c. Alrighty, so this is known as the power rule with a constant multiple. So let's write down what this is. This is power rule with a constant multiple. Alrighty, so let's go ahead and apply it to this particular problem here. So we're finding the indefinite integral of x to the 5th over 2 dx. Note that this can be written as the integral of 1 over 2 x to the 5th dx. These two mean exactly the same thing, okay? So what does this format illustrate? Well, we have a constant multiple, namely 1 over 2. So let's go ahead and factor out that constant multiple. We have 1 over 2 times the integral of x to the 5th dx. Now let's go ahead and find the antiderivative using the power rule of x to the 5th. So we'll have, don't forget your constant multiple now. Bring down the 1/2 times x to the 5 plus 1, power plus 1, divided by power plus 1. And don't forget the plus c. Okay? All right, let's go ahead and simplify that. We're going to have 1/2 times x to the 6th power over 6 plus c. Final answer is x to the 6th over 12 plus c. The answer to question number 1 is option letter D. Alrighty, let's take a look at question 2. On question number 2, we're being assessed on how to find the equation of the tangent line, the EOT. Okay? Alright, so to get us started, let's go ahead and write down the formula that's going to guide our problem solving process. So the formula for the equation of the tangent line, the EOT, is a formula that's interesting. It's something that we've seen before. It's algebra with a hint of calculus, okay? So the formula for the equation of the tangent line is y minus y1 equals m times x minus x1. Take a look at that. This is the equation of a line. It's called the point slope form of the equation of a line from algebra, okay? So where's the calculus here? Well, the calculus is in the m component. You have only one point, and you cannot use algebra to find the slope at a point. You need to use calculus, okay? So m is basically the derivative at x1, f prime of x1. So you have algebra with a hint of calculus. This is the equation of the tangent line formula. All right, don't forget we have the epic collection of formulas for AP Calculus at our website, mathgotserved.com. Go ahead and check it out. Make sure you have all those formulas mastered in order for you to do well on the AP exam. Okay, so we have our formula down. Let's go ahead and list what we need. Oh, just a side point. Another format that this formula comes in many calculus textbooks is as follows. Yeah, this is the function notation. Okay, so it's y minus f of a is equal to f prime of a times x minus a. Okay, so this is another variation. These two mean exactly the same thing. This is preferable because it's something familiar, but this notation is sometimes difficult to remember. But if you just use the standard y minus y1 equals mx times x minus x1, you should be able to do it without any problems. All right, so this is just FYI. So let's go ahead and write down what we know and what we need to find in this particular problem. Alrighty, so we're asked to find the equation of the tangent line of y equals sine x at x equals pi. We know what x1 is. X1 is a given x value, which is pi. What is y1? We don't know what y1 is. Well, y1 is basically the function evaluated at the x1 value. Okay, just as this one illustrates, f of a, and a is pi in this particular instance. Okay, so y1 is going to be the function evaluated at pi. The function is sine x, so we're going to be looking for what sine of pi is. What is sine of pi? Let's go ahead and we can use your unit circle, or you can make use of your trig function to figure out what the answer is. So I'm going to show you both of them, okay? So we want to look for sine of pi. In order for that to happen, I'm going to have to draw half a circle here. So let's say this is our nice little unit circle, okay? And we have to locate pi. Pi is equivalent to 180 degrees, okay? All right, so this is 0, this is pi over 2, and this is pi right here. So we need the coordinates. This is a unit circle, so the radius is 1. This is 1, 0. Over here is 0, 1. And over here we have negative 1, 0. Okay, so remember y is sin and x is the cosine. Okay, so in this coordinate point right here, the y coordinate is the sine and the cosine is the x coordinate. So this value right here, the y value, is what sine of pi is. So from the unit circle, we can clearly see that sine of pi is equal to 0. Okay? If you want to use the graph of the sine function, it's not a problem at all. So you just have to remember how your sine function looks like. Your sine function is your nice little s's. All we need is half a period, but let's just draw a complete period. Okay, so let's say we have our sine function right here. Make it a little bit bigger. So when the angles you're evaluating, if they fall on the axis, I find that the graph is faster. Okay, but when it's within the quadrants, like pi over 3, pi over 4, or pi over 6, it's easier to use a unit circle to figure that out. Okay, so there goes your sine function, like an S. Okay, so what is sine of pi? Where is pi? Pi is halfway here. This is pi. This is full cycle. This is 2 pi. So the y coordinate for this point is 0. So you can clearly see that that's why it's 0. Okay, so we have y1, x1. What's missing? We need m. So m is the slope of the tangent line. M is our SOT, which is f prime of x1, or the derivative. Well, let's use a y notation here so we're consistent. So m is y prime at x1, slope of the tangent line, or the derivative at pi. Okay, so anytime you're looking for the SOT, slope of the tangent line, you always want to remember that it's a two-in-one process. Okay, students sometimes combine them into one step and they mess up the problem. So you have to remember that it's a two-in-one process. The first thing you do is you find the derivative. You do the calculus first. Okay, and then when you're done with that, you evaluate your derivative at your specified input value. This is an algebraic process, so you calculate before algebra. Okay, let's go ahead and do it. So y, what is y? Y is sine x. So let's do the first part, okay? So part one, we want to find, I keep saying f, it's the same thing. Y is the f of x. We want to find y prime. What is the derivative of sine? If y is sine x, y prime is going to be cosine x. Okay? Super. We're done with part one, which is to find the derivative. Now let's go ahead and do part two, which is to evaluate the derivative at the specified x value, which is pi. Okay? So y prime is cosine x. So y prime evaluated at pi is cosine pi. All right, so what is cosine pi? Well, we already have our unit circle here. Remember, the y-coordinate is the sine, y sin, and the x-coordinate is cosine, okay? So for cosine pi, all we just need to look for is the x-coordinate of this point here. That corresponds to pi on the unit circle, and we see that it's a -1. Alrighty, or you can use the graph. So let's draw. So this is our sine, right? You want to draw a cosine. It's going to look something like this, something like that. Okay, so there goes the cosine right there. And you can see that cosine of pi is equivalent to -1. Okay, all right, so y of pi, whichever way you did it, either use it, y prime of pi, either use the unit circle or the graph, is going to give us -1. Okay, all right, so what did we just find? We just found what m is. So we have everything we need. Let's rewrite them all. X1 is pi. Y1 is 0, and m is -1. Okay, so what we're going to do right now is we're going to put everything together in the formula that we have up here. Y minus y1 equals mx minus x1, and then we're going to proceed to put it in slope-intercept form. Okay, so let's do it. So we're going to have y minus y1, y1 is 0, y minus y1 equals m x minus x1, which is pi. So let's put this in slope-intercept form. We have y equals, distribute the -1, negative x plus pi is your final answer. The answer to question number 2 is option letter A. All right, let's take a look at question number 3. In question 3, we're going to be learning how to apply the chain rule in finding the derivative. Okay, all right, so let's go ahead and write down what the formula is for the chain rule. Okay, so if you have how do you know when you're using a chain rule? When you're looking for the derivative of a composite function, a function inside a function, okay? So let's say you want to find the derivative of f of g of x. So you're going to find the derivative of the outer evaluated at the inner times the derivative of the inner. Derivative of the outer evaluated at the inner times the derivative of the inner. Okay, so just this real quick. All right, one common mistake that students make that you want to watch out for is this. They do f prime of g prime of x. They simultaneously differentiate the outer and inner and compose. That is incorrect. Okay? What if you have three functions composed with each other? What if you have f composed with g composed with h of x? This is the same thing, same procedure. You do the derivative of the outermost, evaluated at the composition of the two inner functions. And then you do times the derivative of the middle function, evaluated at the innermost function, times the derivative of the innermost function. Okay? This is known as the two chains formula. You're doing chain rule twice. Okay, so let's go ahead and differentiate this function right here. So we have the derivative of 3 times tan x squared raised to the third power. Okay, so one thing you want to know is that if you have a constant multiple of your derivative of what you're differentiating, you can always factor that out, just like you do with integrals, right? So pull out the 3, so we have 3 times the derivative of tan x squared raised to the third power. Something to note is another way to write this, you can also write this as 3 tan cubed x squared. These are exactly the same thing. Okay, so two different notations for writing the power of trig functions. Okay, so what we're going to do now, we're going to go ahead and apply our chain rule here. As we can see, this is going to be a double chains problem. Why is that? Well, it's because the inner function g is also a composition of your tan and your quadratic. Okay, so we're going to break it down so that nobody gets confused here. So let's start by breaking it down. The outer function, let's call that f. So f of x is your outer function. Okay, some textbooks refer to it as u, f of u. Okay, so it's like u to the third. And then the inner function is your composite function g of h. I'm just, for the sake of simplicity, let's just call it g for now. Okay, so g of x is tan x squared. Okay, so you differentiate both. So the derivative of the outer function is 3x squared. And then the derivative of the inner function is another chain rule. Let's save that for later. Okay, I'm just going to write it as something to be differentiated later on. We'll do it one at a time so we don't get confused. I know some of you are superstars. You can do this with your eyes closed, but I just want to make sure that everybody understands exactly what's going on. Okay, now let's see what we have. Applying the chain rule, this derivative in its intermediate form is going to be, don't forget the 3 times the derivative of the outer evaluated at the inner. So we're going to take the inner function and plug it into the outer function. Nope. Plug it into the derivative of the outer function, that's the dou, and then we'll multiply that by the derivative of the inner function, which is another chain rule. Okay, so we have 3 times we have another 3 here, so it's easy to mess that up. So we have a 3 here, so don't forget there was a 3 that we brought down, and then we have this 3x squared. So instead of x squared, we're going to put in the inner function, which is quantity tan x squared, and then that's raised to the second power. Alrighty, and then that will be multiplied by the derivative of the inner function. Bam. Okay, so now what we're going to do is we're going to apply the chain rule again in finding the derivative of the inner function, in finding the derivative of g of h of x. Okay, our formula here clearly shows us what it is. It's g prime of h of x times h prime of x. That's what it's going to be. Okay, so let's go ahead and find the derivative of the inner. Let's see what we're trying to do here. Want to find tan x squared prime. So let's break it up again. Our outer function is f. Well, let's color code it. So our outer function is f, is a trig function. Okay, so that's tan x, and then our inner function is g, which is x squared. Okay, so what we're going to do is exactly what we did here, okay? Differentiate both functions, the outer and the inner. So derivative of the outer function is secant square x. Secant square x, or you can say secant x squared. Let's use secant x squared or secant square x, the same thing. And then the derivative of an inner function is 2x. The reason why I'm using this notation is because I'm looking at the options here and it's using secant x squared quantity square. So let's use that format. All right, so what's the derivative? We're gonna do this derivative of the outer secant square x or secant x squared evaluated at the inner. So we're going to take the inner function g and plug it into the outer function that's equivalent to g prime of h of x. Okay. All right, and then we're going to multiply that by the derivative of the inner, which is h prime of x. So the derivative of tan x squared is going to be secant. So instead of having our x, so let me show you something real quick just to make sure you see exactly what's going on. This inner function right here is going into just the x. It's going right into the x spot. Don't get it confused, okay? It's going right into the x spot. So it's going to become secant. Instead of x squared, we're going to replace it. Instead of x, we'll replace the x with x squared. But this entire thing is being squared. So secant x squared times the derivative of the inner, which is 2x. Okay? All right, so to bring everything together, what we're going to do is as follows. We're going to take this answer we just got, and we're going to plug it in right here for the derivative of tan x squared prime. Okay, I mean the derivative of tan x squared. All right, so that's why I broke it down so it doesn't get too messy. All right, so this becomes 3 times 3, which is 9. 9 times tan x squared. Then the derivative of this is secant x squared quantity square times 2x. Okay, so we can combine this 2x and the 9 together. If we do that, we're going to have the final answer 18x tan x squared times the quantity secant x squared. Ladies and gentlemen, that's the final answer for question number 3. Okay, so let's see which one is the answer. Answer to number 3 is option letter C. Alrighty, let's take a look at question number 4. Question number 4, we're going to be assessed on how to integrate composite functions. Okay, so question 4 reads, was the integral of 2x to the third plus 3 over the quantity x to the fourth plus 6x minus 8 squared with respect to x. To get us started, let's go ahead and write down the formula for our problem solving process. Don't forget, we have all the must-know formulas at mathgotserved.com to check it out and download it and make sure you have it all mastered. Alrighty, so the formula we're going to be using here is known as the chain rule I'm sorry, not the chain rule formula. Let me not specify what it is. It's the reversal of that. Okay, so if you have wrapper, which integration technique here are you going to use? Ladies and gentlemen, we're going to be using the U substitution. Okay, it's called the U sub. It's related to the chain rule. Actually, it's like undoing the chain rule, kind of, sort of. All right, so what's the U substitution formula? If you're integrating a situation where you have a composite function, let's call it f of g of x times the derivative, or the derivative of the inner function. This can be rewritten as the integral of f of u du. Okay, this happens where we have the inner function assigned the value u. Okay, so remember, u substitution doesn't execute the entire integration process. It's just a tool to condense the integration problem into something that's more manageable, something that's more elegant and easier to integrate. Then after you integrate, you don't forget to resub your value back for u. Okay? All right, so let's go ahead and get started here. So we're integrating this guy right here. So let's write it in this format. I'm going to write it as 1 over x to the 4th plus 6x minus 8 times 2x to the 3rd plus 3 dx. Now, how do you know to use the u substitution? Well, if you take a look at the inner function of the composite and you differentiate it, and you end up with a multiple of the other function, guess what, ladies and gentlemen? That is a u substitution problem. Okay? All right, so in this particular case, check this out. We're going to call our u this inner function right here. Okay? So u is going to be, let's put it over here, u is going to be x to the 4th plus 6x minus 8. Now, if I differentiate this and end up with a multiple of this function here, I know for a certainty that u substitution is the way to go. All right, so differentiate both sides. The u is du dx, but I'll put the x on the right side. Okay, so differentiate this. This is 4x to the 3rd plus 6. Du dx, you put the dx over here. It's faster that way. That's not a perfect match. But wait a minute, what if I factor out a 2 from here? What do you notice if I factor a 2 from here? I'm going to have du is equal to 2 times 2x to the 3rd plus 3 dx. Jackpot. You see, I got du is twice this. Okay, so whenever I differentiate, I end up with a multiple of the derivative of the inner irrational number multiple, then you know that you can integrate using u substitution. Okay? All right, so now we know what u is. We know that we're going to be using u sub. 2x to the 3rd plus 3 dx is du, but I have, this is a second function. So what is du exactly? 2x to the 3rd dx, I have 2x to the 3rd dx, but wait, we have a 2 here. That's a problem. How do we fix this problem? I want this exactly. My substitution must be clean. That's critical, okay? I need to have 2x to the 3rd dx with no extras. This is an extra right here. So how do we fix that? What you do is you divide both sides by 2, okay? So you divide by 2, and you have your perfect clean substitution. You know that du over 2 is going to replace the derivative of the inner function. Twice the derivative of the inner function. Okay. All right, so you have that right there. Okay, so this piece right here, we're going to replace it with du over 2. Now we can rewrite it. It's going to substitution. We're going to have the integral of 1 over u squared. And then this entire piece right here is du over 2. Okay, so let's get this 2 out of the way. We're going to factor it out using the constant multiple rule. So we have a nice looking integral. 1 over u squared du. Now, how do you integrate 1 over u squared? Is there any formula for that? Well, there isn't. So what are we going to do? We're going to rewrite, okay? Rewrite this. So if we rewrite this, it's going to be 1 over 2 times the integral of, using the reciprocal property of exponents, u to the negative 2 du. Now, guess what? We can apply the power rule. Okay, we went over the power rule in question number 1. So let's go ahead and do that. If we apply the power rule, this integral is going to become 1 over 2 times u to the power plus 1 divided by power plus 1. Since it's an indefinite integral, don't forget plus c. This becomes 1 over 2 times u to the negative 1 over negative 1 When we simplify that, we're going to end up with negative, 1 over 2u plus c. Okay? All right. Are we done yet? No, we need to resolve, okay? What's u? U is x to the fourth plus 6x minus 8. So we're going to plug that in here. So this becomes, I'm going to structure it exactly as the options are in the alternatives. So we're going to write it like this. This is going to become negative 1 over 2 times 1 over u, which is, what is u? X to the fourth plus 6x minus 8 plus c. Okay, if you wrote it like this, 1 over 2 times x to the fourth plus 6x minus 8 plus c, that's correct. But in this particular option, they just separated the coefficient as a multiple of the rational expression. Alrighty, so we can clearly see that our answer is option letter C. Alrighty, let's take a look at question number 5. Okay, question number 5, we're being assessed on how to determine the intervals of concavity of a function. Where is it concave up or concave down? Okay, so to get us started, let's write down the formula that's going to help us to solve this problem. So all you just need to remember is that f of x is concave down on an interval, let's say AB, if the second derivative is less than 0 there. Okay, so if the second derivative is negative, you have a downward opening concavity. If the second derivative is positive, then f has an upward opening concavity. So in this particular case, we're looking for where f is concave down. That's why we're looking at where f double prime is less than 0. All right, so just to help you recall, we are going to use an easy way to remember this is your fun chart, right? So let's look at the fun chart real quick. So f concave up, concave down, f prime increasing, decreasing, f double prime positive or negative. Okay, so this is very important. You can use f prime or f double prime to determine the concavity, okay? If you know the behavior of f prime, you can determine the concavity of f. All right, this particular row right here where f prime is increasing or decreasing is helpful when you're dealing with a graph. If I give you the graph of f prime, then you can determine where it's increasing or decreasing and easily determine the concavity of f. But when you're given a function of f, you want to use the second derivative because you can easily determine the sign of the second derivative around the critical values of the second derivative. Alrighty, so remember this one is use f double prime algebraically, and then use f prime graphically when you are finding the concavity. F double prime, you can use algebra or graph, it doesn't really matter, but this is faster for algebra, okay? Okay, now let's see. Where are we at? So we're starting with the function f of x equals 6x to the 5th minus x to the 6th. Since this is an algebraic representation, we need to find the second derivative, okay? Find the second derivative and then look for the critical values of the second derivative and figure out what intervals around the critical values do we have a negative sign for the second derivative, okay? All right, let's do it. So we're going to be using the power rule twice here. So the first derivative, f prime of x, is 30x to the 4th minus 6x to the 5th. Do it again. F double prime of x is 120x to the 3rd minus 5 times 6, 30x to the 4th. Okay, so we need to find the critical values of f double prime. Next, So find critical values of f double prime. What on earth is that? What is the critical values? The critical values are basically where whatever you're looking for the critical value of is equal to 0 or d/any, okay? So we're looking for where f double prime of 0 is f double prime of x is equal to 0 or f double prime does not exist. Those are critical values. So we just take, so let's do the first one. Let's find where f double prime of x is equal to 0. So we have 120x to the third minus 30x to the fourth. Solve this algebraically for x. Okay, so set equal to 0, solve for x. What can we factor out? We can factor out the GCF, 30x to the third, which leaves us with 4 minus x equals 0. Using the zero product property, we set both factors to 0 and solve. If we solve the first one, just divide both sides by 30 and you have x to the third equals 0. Take the cube root of that and you have x equals 0. Your first critical value is x equals 0. And then for this one, just add x to both sides. X equals 4 is your second critical value. Where is the second derivative? Non-existent. This is a polynomial function, so it's smooth and continuous, okay? The denominator is 1. So you're looking for where is 1 equal to 0? It's never. So this function is defined on the entire real number line. So we don't have to bother looking for where it does not exist. We just look for where is equal to 0. Okay, we have our critical values. Now we're going to use our sign chart to determine what the concavity of the function is about the critical values. All right, so we don't have any constraints on our interval, so we have a real number line. Critical value number 1 is 0, and then the second critical value is 4. So let's put our partitions up so we have a clear visual restriction on what we're working with. Okay, now what we're looking for is the sign of f double prime. Ladies and gentlemen, I'm going to use the factored form. Okay, it's much faster. I'll tell you why in a second. So sign of f double prime, running out of space here. So that is, let me see, 30x to the third times 4 minus x. Okay, so the sign of f double prime, that is going to tell me the behavior, namely the concavity of f. Okay, all right, so we have two intervals, actually three. Sorry, we have interval 1, 2, and 3 to test. So we need to pick numbers that satisfy the interval. So for the first interval, let's use x equals -1. For the second interval, x equals 1. For the third interval, x equals 5. Ladies and gentlemen, all we care about is the sign. What does that mean? You do not have to evaluate the expression completely. You just have to figure out what the sign is and go from there. Okay? All right, so for x equals -1, we have 30 times x to the third. What is the sign of 30 times x to the third? What is it going to be when you plug in -1? Since you're raising -1 to an odd power, is going to be negative. So it's going to be negative for that. And when I put in negative here, 4 minus -1 is positive. Notice I didn't do the work. I just figured out the sign, okay? Because time is of the essence here. Minus times plus is minus. That tells us that f is going to be concave down on this interval because f double prime is negative. All right, let's move to interval 2, x equals 1. When you plug 1 here, 30x to the third, that's going to be 1. I'm sorry, positive. When you plug 1 in here, 4 minus 1 is 3, which is positive. So your sign is positive. F is going to be concave up because f double prime is positive. And then lastly, for 5, plug in 5 here is going to be positive. 4 minus 5 is negative 1, so it's negative. Plus times minus is minus, so f is going to be concave down. So do you see what the answers are? F is concave down on two intervals. F is concave down on negative infinity to 0 and 4 to infinity. Because why? Because the second derivative is less than 0 on those intervals. Alrighty? So the answer to problem number 5 is option A. Alright, now it's your turn to do some practice problems. So what we'd like you to do is go ahead and pause this video presentation at this time. We'd like you to try these 5 problems to assess how well you've mastered what we just covered in this presentation. When you're done, click on the playback button. We are going to display what the answers are, and then you can basically check your work to see how well you did. Alrighty, welcome back. So hopefully you had a chance to try the problems. So these are the answers. Answer to question number 1 is C. Answer to question number 2 is C. Answer to question number 3 is B. Answer to question number 4 is D. And answer to question number 5 is C. So how well did you do in these practice problems? Well, let us know in the comment section below how well you did. And if there are any questions you want us to clarify, just specify it in the comment section below and we'll be more than glad to assist you. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your preparation for your exams or calculus in general, do give us a like. Your positive feedback is very, very helpful to us. Do not forget to subscribe to our channel for updates to other presentations such as this. As indicated earlier, if you have any questions or comments, just post it in the comment section below. If you'd like to gain access to our epic formula sheet and other valuable resources to help you do well on the AP exam, do visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.